plan book is same as yesterday. I want to make you guys aware of something that right now is still in the creation phases, but I went ahead and posted it and made it live to help you guys be able to check your answers. So when you log into Schoology, and let me zoom in a tiny bit so you can so when you log into Schoology, you have your home page, right? And whatever you have subscribed to, you'll probably have some posts from people. When you click on courses, make sure that when you're going to my course, it's the one with the picture. I think most of us have that sorted out. Right here is how you can reorder your classes. If you would like to drag one of the classes that's real above the classes that are fake, these are fake classes. The district makes those. I can't even delete them. Grab the arrow and drag it up. Now it's not summer, so I don't need my summer class, so I drag that down and I leave it somewhere below. So do that. Drag whatever class you want to the top. Obviously, math is the best and should be on top. And then you would go to my math class, and of course, here's the updates. In the materials page, first thing up here now says math practice feedback, October 30th to November 3rd. You are not expected to fill this in right now. You're not expected to complete anything. Mr. Smith and I are still making up what we're going to expect out of you guys. However, instead of using that paper homework feedback form, like, let's be honest, who doesn't know where that feedback form is that I gave you guys a week ago? Who knows right where it is and you filled it out last week like you were supposed to? Yeah, see, that's kind of what I thought, right? So not many of us did the paper feedback form because it was still like a little weird. And honestly, if we're getting on Schoology to check our answers, I was thinking, why not just have the feedback be on Schoology? So check it out. Right now, you can complete this. You may type stuff in, but I'm not expecting that you do right now. So you'll see here it says, below are the answers to this week's practice problem. Sorry, if I go to preview, that's actually what I should go to. So instructions will say when you hit start attempt, you'll see this week's answers. You may submit this up to 5 times, so you could do it on a nightly basis. Now I'm still making this up, so these directions might change. Long story short, if you hit start new attempt, right now, you'll get all the answers for this week's practice. They're all in here. So then if you had any questions from Monday, you could say, from Monday's 3.2.2, which you wouldn't have to type that, but you could say whatever questions you have there. And then Tuesday's homework is question 2, and there's all the answers. And a blank box where you can type issues. Wednesday's homework, and then Wednesday's homework was the same as Tuesday. So this is tonight's homework right here. And then we have what will probably be Friday's maybe. So that's still a maybe, but I went ahead and posted those answers. So for you to check your answers this week, just go to your materials page. Materials, not update, materials. Click on math practice feedback, start an attempt. Sorry, for you it'll look like this. Start an attempt and you can check your answers there. Any questions? Good? Sweet. Awesome. So moving on. Today we are in 3.2.4 talking about multiplication of decimals. So everybody has one of those hundredths grids, right? Yes, we have the resource page. Please get it out. Have it in front of you. We are going to need it. That hundredths grid resource page. Hundredths grid resource page. Hundredths grid resource page. Looks like some people took multiple because I had plenty.
No, I got it out.
Oh, you grabbed the stack, sweet. All right, so what's decade mean? A decade. If I tell you I did something a decade ago, which I can tell you a lot of things I did a decade ago, 10 years, right? Deca means 10. It is actually a root that means 10. So decade means 10 years, and decimal, deci with an I, not an A, means a tenth. So decimal starts to break things into tenths. So tenth or a tenth of a tenth is 100th. A tenth of a tenth of a tenth is 1,000, and it keeps working like that. So we fortunately, and at some point I'll show you guys videos about base not 10 systems, like a base 8 system. Or anyone here ever heard of binary code? That's a base 2 system. There's only 2 digits in the whole system, 0 and 1. So today we're talking about decimals, right? Base 10 system, things are easy for us. What we really want to keep in mind as we go through is how are these decimals like fractions? If you can name something as tenths or hundredths or thousandths, you can quickly get it into a fraction. What does place value have to do with our answer, and does our answer make sense? So we're going shopping. I love shopping at the sporting goods store. REI literally has all of my money. Not literally. I shouldn't say things like that. But so Howard's going to the mall, and the sporting goods store has a sale where all goods are 10% off. So 10% off. There's a few ways that we can think about this. 1/10 off would be like the fraction form. Now, I don't really feel like the store would hang a banner that says 1/10 off. They'd probably say 10%. So with your team, follow the steps below to help Howard determine his savings. So using your hundredths grids, we're going to start to shade some things in. So I'm first just going to give your team time to process through A through G here and figure out how we can use the hundredths grid to visually represent how we find 1/10 of the price of his shoelaces. So take some time. We'll give you a few minutes. Talk with your team about how to use that hundredths grid, shade stuff in. I'm going to bring around some packs of colored pencils. Color coding helps a lot. It like activates your brain. So if you want to use some colored pencils, please do so. Share these with your team. And actually, if you front tables want colored pencils, let's just have you grab over here if you want. You guys should be working together, talking. So, now, because we're using your hundredths grid today, if I was you, I'd throw a date on here. It's 11/2. We're using this first on lesson 3.2.4. But also in my notes, that just goes up here. It's like giving them a mint. You're gonna like it.
That's what I used to do.
Yeah. Like the area of one of these things. Now with perimeter and area, did you label? If you did not label it right now. Mr. Cooper, what did you get for your perimeter here, the distance all the way around? 40 units. We don't know what the label is, so we label it units. What about Grant, our area? It is 100 units squared, and you can abbreviate that as just U with a power of 2. U is our abbreviation for units. So then B asks, what do each of the small squares in the grid represent? Write your answer in all 3 forms. Check, did you write your answer in all 3 forms? Penelope. This is why I should take cards out, but thank you guys. That's good. Zoe, I know you're here. What does each little bitty square represent? What is it? Sorry. 100. Now that's one of the forms. Can you give me the other 2? What if I say the same thing you just said, but make it a decimal? How can I write that? Yep, 0.01. And then if I go to make that decimal into a percent, we know, I would show this on your paper if you haven't shown this, we just move the decimal 2 places. Always converting with percent, we move 2 places. Going into percent, we move right. Coming out of percent, we would move it left, but this just becomes 1%. Each box is 1%. So we could show percents less than 1 by shading less than a whole box. So then it says, why do you think these are called hundredths grids? Why do you think it's called a hundredths grid? Yeah, there's 100 in the grid. Each one's worth 100. We can figure that out, right? So that's pretty obvious. D tells us to shade in for 40 cents. So 40 cents is 40 out of $1. We want to shade in 40 of these. So I'm going to block it out and then shade it. So please make sure you've done this. Now here's where it gets a little tricky. It then says that in the other direction, we want to label 1/10 of the grid. Why? What are we trying to do at the sports store? Grant? Yeah, and our end goal is to figure out how much we owe them, right? So finding 10% is a step along the way. I got to find out what my price is, what I'm going to have to pay. So the other direction, shade 10% of the rectangle. This is why I told you to color code. The part of the hundredths grid that has been double shaded is your answer. So we could write out for F, I'm just going to erase C and D here so I can just jump right to F. For F, we could write out, what are we calculating? How do I write this as an expression? What did we do? What math? We found what of what? Nathan, you look like kind of bored. What did we find today? What was the sporting goods discount? What was their sale? 10%. So we found 10% of 40 cents. So we found 1/10, right? They said 1/10 off of 40 cents. We know it's 40 out of 100. Now I could also write that as a decimal, right? 0.1 times 0.40. This is where people get goofed up. Because if I have just 1 and just 4, right? 1 times 4 is 4, and a lot of times I end up getting an answer of that. Don't write that. Please don't write that. That is not correct. Thinking through the fraction form of these values will make your life easier. This is a common mistake because people say, yeah, 1 times 4 is 4. They were both in the tenths place, So here's how we want to do this accurately and when fractions are better. And there's a lot of times when I think fractions are better. What can I do with my 40 hundredths to make life easier? Patrick? How do I do that? First off, I can chop off stacked zeros, and actually that's easy enough. I could keep simplifying, but that's easy enough. I'm just going to work with that. How do I multiply with fractions? Kate? Straight across. Through the top, through the bottom. When I go through the top, what do I get? So I get 4, but when I go through the bottom, what do I get? Hundredths. So my decimal answer is 0.04, which actually, in this case, is 4 cents. Because this 0.04 is dollars. That's how much money you'll save off those shoelaces. Now, obviously, 4 cents, not very much. But it's better than what it would have been. This is to make you make sense of what we're doing. Now, if you were buying something that was $40, not 40 cents, then you would care a lot more. This is just to set up the visual of why this makes sense. Any questions on this one? 64. Yeah.
The part A, the area, is that just one square unit divided into 100 parts, though? In the instructions it says that it's a unit, so I think it's easy. It would be obviously a 10 by.
Yeah. So what depends on how we look at it, is what you're saying, right?
Right. If it's a 1% of the whole, then the whole is 1 square unit of 100 parts. So I just don't want that to be because it's physically it is 100 square units, but they're asking you to represent it, I think, in your imagination as 1 square unit.
Do you guys understand what Mr. Smith is saying? No. So we can look at this problem in 2 different ways. If we look at it like we are used to looking at things, like we did on the mastery, which really we're going to say there's 2 different answer sets for A. If we look at this like we did from the mastery and count individual boxes like we do on our graph paper, right? We get 40 edges as we go around and 100 boxes as we go in there. But if we look at this slightly differently, and just somewhere else on your paper, you have way too many hundreds grids. I gave you twice as many as what they even wanted. You have a bunch of these. So somewhere else near the bottom of your hundreds grid, we're going to give a different situation. So if that represents 100% of something, what value did we say, decimal value, represents 100%? 1. So that's what Mr. Smith is saying, is if we're looking at this using this as a percent model, this area is actually 1. It's a whole unit. It's 100%. It's 1. So If we talk about the area as 100, we have to know that these 100 units, each unit is only 1%. They're 0.01. Or, if we relabel it like this, our area, so please somewhere on your paper jot down that we can also think about area is 100%, because that's what this is representing, is the entire area is 100%. I see the people that aren't writing, it's rather obvious. And that 100% really equals 1, but we're not even going to label that. We can, I guess. It'd just be 1 square unit if my square units are the big thing. So we can either look at it as 100% cubes, squares, sorry, 100 little bitty percent squares, or 1 giant unit square. Now the extension off of this then, if the area of this equals 1, because each of the little bitty guys is 100, what's the perimeter? Ooh, Kate's hand went right up. 4. It's all about perspective. You get that all down, Nathan? 65. Check it out with your team. Thanks for that, Mr. Smith. If you were to write this out, you'd be looking at 70% of the old shoes. And we're talking weight. But remember what of means. So I'll stop talking. There are multiple correct ways to do this. People at your group might do it a couple different ways. There's multiple right ways to do this. So on your hundredths grid, you're going to be filling in 70% of 8/10. Where's your hundredths grid, man? Yeah, we're going to use this all day long. So make sure that we're shading in. Okay, that's just a little, like, pretty light. Make sure that we can see it. So grab some colored pencils if you want. I would use 2 different colors, like not red and orange because they're super close to each other. Okay. And be careful if you're missing a couple boxes. That wouldn't really make sense if you were trying to explain this to somebody. So make sure you shade it clean. Take a little bit of pride in what you're doing. Even if we're just shading in boxes, make it kind of clean. 2 different ways to do this. You can do 0.7 times 0.8 or 0.8 times 0.7, right? Multiplication's commutative. The order can change. Seen most people with their shading done in one direction. I think a lot of us started with the 70% vertically. It doesn't matter which you do. So I shade in 7 of these columns. Right, and we 70%. Turn the other direction, shade your other portion. So my other portion, 80%, I've got almost this whole thing shaded. Can anyone tell me the easy way to figure out how many boxes get double shaded? I know how many boxes of the red will be covered by the blue? How do you know to multiply 8 by 7? I completely agree, but... I love it. Give me your eyes up here for a second. Look at the rectangle that got double shaded. What's its width? 7 of the little boxes, right? What's its height? 8 of my little 100th boxes. What's 7 times 8? 56 of the little tiny boxes. What is each box worth? 100th. Right? So if I have 56 of the 100th boxes, what's shaded in? 56 hundredths. And I could write that as 56 out of the 100 to get me to my decimal. You shaded in 56 of the 100 boxes. It's what's double shaded. Now, what the heck does that tell me? What is that 0.56? Why do I care? I need to figure out what the label on this would be, right? Alex? How do you know that? Our answer is how heavy our shoes are going to be. How are we talking about weight in this problem? Kilograms. So my answer has to be about weight, has to be in kilograms. Bless you. We could also show this alternative way to get there. 7 tenths times 8 tenths equals, straight across the top, straight across the bottom, 56 hundredths. Anyone ever realize that really cool, like 8 times 7 makes 5 times 6, and they're all like right next to each other? 8 times 7 makes 56, or 7 times 8. All these numbers are right next to each other. I just think it's kind of cool. 5, 6, 7, 8. 56 is 7 times 8. So I used to really like writing weird math things like 5, 6 is 7, 8. 5, 6, 7, 8. I was a nerd. It's okay. I was just killing time while we make sure everybody's caught up. We all good here. How we get to 56 hundredths. Now the same will hold true even if we're not working with values that are less than 1. We're just doing this right now with all values less than 1 so that we can use our hundredths grid. And obviously the new one's way less, right? 56 hundredths is less than 8 tenths. This is where people try to shortcut. We've talked about this being something that people have kind of been trying to avoid. I don't quite know why, because the generic rectangle is literally like your best friend when it comes to multiplication. So everybody, please, in your notes, draw a generic rectangle. I'll just draw it with you. Forget it. I won't copy paste and be lame like that. Draw a generic rectangle. Now, what do you notice about this generic rectangle as opposed to just any old one? Is it cut straight in the middles? No, they're trying to show how big things are. So, if we go 2 wide and then a little chunk, so 2 wide and then a little chunk, 1 wide and a little chunk. So this isn't quite perfect, but it's trying to show relatively that last line. Probably something like that. So we are splitting up 2.3 by saying it is 2 3 tenths times 1.4. So please make sure that somewhere either above this or near it, you have notated that the problem we're doing is 2.3 times 1.4. This is going to be way easier than you realize. Because everyone's like, why do I have to draw this rectangle? It's more to do. It's really less to do because it makes the math easy. What's 2 times 1? 2. What's 1 times 3? 3, then we have 1 decimal place, so we have to keep 1 decimal place. What's 2 times 4? 8. We have 1 decimal place, so we have to have 1 decimal place. Here's the part that people will goof up. What's 3 times 4? 12. How many decimal places do we have? 12's got to use 2 decimal places, so it's 0.12, not 1.2. That's the most common mistake. People think like, oh, we're multiplying, it gets bigger, it's 1.2. No, that's 3/10 of 4/10. We're getting smaller, right? That's what the unit or the hundredths grid should be showing. If I shaded 3 columns and then 4 rows, I'd get 12 of the 100 squares. Then we sum this together. So 2 obviously is 2. 0.3 and 0.8 is 1.1. So as I think this through, I got 2, 1.1, and another 0.12. I can combine these, and that's 1.22. If I add the 2, and of course you could use some sort of aid if you need. 3.22. Question? Once you get the box filled in, it's just adding them up. So we could do 2.8, then add 0.3, end up at 3.1, add the 0.12, end up at 3.22. However you want to add those up is up to you. Some people want to start with the small numbers, like the small portion. Some people start with big. I start with big. Questions? Generic rectangle multiplication. When it asks you to do this on your homework, you need to use the generic rectangle. Please and thank you. So try 67 with your team. Well, hold on. We should have, I want to make sure that we get through this. We should have tried the generic paper pencil multiplication on our own. But let's just say we did, and Judy's a member of our team, and Judy has this as her work. Right, so what do you need to do to help Judy make sure that she gets this correct? And then, how does my generic rectangle relate to what I see right here? So talk as your team. Can you figure out the relation between the generic rectangle and this multiplication? And actually, I'll make that one worth candy. We'll do that. I'm still in Halloween mood. And what do you need to modify here to make it work? Take 2 minutes. Probably got time for that one. So if I was you, I would jot this on your paper and just work with it on your paper. So can you see the relationship between the long multiplication method and the generic rectangle? where?
So 92. I'll jump right into it. Where do you see 92 in the generic rectangle? Right, because that one. And then what about 230?
So can you articulate that, and I can highlight up here and show exactly what you just said? In about 30 seconds, Ella's going to tell us what she figured out with this. So Ella, before we dive into like what they need to modify down there, if I just look for 92 or 230, comparing it to my generic rectangle, where do I see anything like that? Give me your eyes up here, if they're not up here right now. 92, hold on just a second, Ella. Ella just said, look at the bottom part. Well, 8 tenths can also be written as 80 hundredths. 12 hundredths, 80 hundredths. What's 80 plus 12? 92 hundredths. 2 could also be written as 2.00 and 0.3. So keep going, Ella. Do you see it now? All the generic rectangle is doing is making your old-fashioned method of multiplication visual. It's doing the same thing that we did before, but making it visual so we understand it. Now, they have a slight issue down here, right? Judy's got some minor problems. Ella, help me fix Judy. So this is in the wrong place, needs to be bumped. This is in the wrong place, needs to be bumped. Because Ella said we gotta have that decimal. So my decimal would go here and here. Getting 3.22. Now I'm not saying the old-fashioned method of multiplication is bad, but it just doesn't really show you why you get what you get. The visual model shows us why we get what we get. Questions? Sweet. Now, when we look at what the 92 is and how we get that and why it's not 92, why it's 92 hundredths, the values that we multiplied to get there, right, had those decimal places, but still, it's one of those, like, rules. It's that stuff you have to remember, like, oh, I got told to do this. As opposed to, up here, it makes sense. Really, I would advise using the generic rectangle over the stacked multiplication where you have to drop decimals and keep things all lined up and goofy, add a 0 and scoot things over. I hate rules, right? Who wants to follow rules? Let's just do things that make sense. Moving on to 68. Try this on your own real quick at your group. 3/10 by 16 hundredths. Show 2 different ways to do this. 2 ways to do this. 1 decimal, 1 fraction. You may still use your hundredths here. But weird. 16 hundredths. Let's before we run out of time to get out of here, if you set this up for fraction multiplication and use 3/10 and 1600ths, please make sure you have this written because you'll do some of these on your homework. We go straight through the top, straight through the bottom. 3 times 16? 48. 100 times 10 is 1,000. So then we get 48 thousandths, which means it needs to be 0.048. We're out of time. We will likely not really take time to finish this lesson. So if you have homework questions, please bring them tomorrow. I would like to go over homework if needed tomorrow. Did anybody accidentally take a package of colored pencils from here yesterday? I'm missing one of my packs of colored pencils. So if you find out that you have 2 packs accidentally, please bring me one back. I would love my colored pencil back. Thank you. So Liam, I'm going to assume that those are your colored pencils. Okay. Just making sure. They all look alike, right? Just one. Thank you. Have a good day, guys. Okay, some of that's a repeat from yesterday. And yesterday I was really nice about it. So let's not give me a hard time. I gotta get my